Hello, everyone, and welcome to the Trenchless Technology webinar series. My name is Sharon Bueno, Managing Editor of Trenchless Technology magazine, and it's my pleasure to introduce and moderate today's presentation. Before we get started, we do need to take care of a few housekeeping items. First off, we're going to take a quick poll, so please submit your answer and then click the blue Return to Presentation button. Also, during the presentation, we encourage you to participate in the webinar by typing in your questions into the designated panel in the left-hand portion of your screen. You can also maximize your viewing window by clicking the box with the X at the upper right of the slides. Today's webinar is presented in part to mark the first ever World Trenchless Day that's taking place today. It's a day of global celebration that shines a spotlight on all of Trenchless Technology's benefits, from the safety to economics, environment, and soils. There are lots of activities going on throughout the world today, and we're glad to have this webinar as part of it. Trenchless Technology, as you know, is an exciting and dynamic industry that continues to expand and evolve. Today's presentation focuses on what is widely considered to be the original Trenchless technology, chemical grouting, or it's more referred to today as injection grouting. And today's webinar is sponsored by one of the pioneers of the grouting industry, Avanti International. This webinar promises to be a very interesting hour for you. Today's presentation is titled, Reliving 50 Years of Municipal Grouting and What's Next. To help facilitate, I'm calling on Donald Rigby, Vice President of Marketing and Education for Avanti International, to introduce this documentary and manage the interactive poll questions you'll be seeing. I also want to tell you that, as a quick reminder, there will not be an open Q&A at the end of the presentation, but your submitted questions will be answered in a FAQ document within weeks afterwards. Before I hand things off to Dawn, I also want to remind everyone that at the end of the presentation, please stay with us, because Trenchless Technology magazine editor Jim Rush will be joining us to host another webinar event, which is the announcement of our 2016 Trenchless Technology Projects of the Year winners for rehabilitation and new installation. So with that, I'm going to hand things off to Don.
Thank you, Sharon. And we will stay tuned after this webinar for the next presentation. I think it's the first time you've ever done a back-to-back piggyback presentation. We'd like to be part of first, that's for sure. I think it was earlier this year at the No Dig conference in Dallas that you and I spoke, and you first made me aware of the World Trenchless Day, September 22nd. I thought, how convenient. Chemical grouting, now known as injection grouting, is the original Trenchless technology, and this is the year that Municipal grouting celebrates its 50th anniversary. And I thought, this sounds like a celebration, but not a standard one. I want to do it online so that more people can join in. I wanted to be on point with multiple voices and perspectives, and I wanted this to be on people who have made a difference in our industry. So yes, we will recognize a few grouting greats, many of whom are no longer with us. We will look back into the early days, 50 years ago, appreciate how far we've come as an industry. And yes, innovation is alive and well within the grouting industry, and specifically for municipalities. Perhaps most important, we will take a look at what we might expect in the coming years, 2 years out, 5 years out, 10 years out. I think I'd like to take a moment to ask a question, and there is no wrong answer to this. I'm going to ask your opinion. What is the greatest value of, let me send this out. Boom. What is the greatest value of Trenchless technology to our society? Your options are safety, economics, environmental impact, and social. Just give me a quick answer. I'm not going to hold this out there very long because I want to keep moving. We're going to dedicate all 60 minutes to content today. So I'm going to go ahead, hit OK. I'd like to send the results back to our audience. Let me do that right now. Survey results sent successfully, except that I can't quite see it. It looks like greatest value was less disruption to everyday life. Is that right? Yeah. Very good. Our first presenter, let me go back to the slides. Our first presenter, someone that I've come to admire. He has a big voice in the trenchless and the grouting industry. He's an engineer, he's a musician, and the executive director of NASSCO. Thank you very much for being here today, Ted DeBoda.
Thanks, Don, and happy World Trenchless Day to everybody. We're really proud to have the ICGA, and that's the Infiltration Control Grouting Association, as part of NASSCO. The ICGA was formed in 2002, and they've really made a lot of great strides in standardizing and educating the industry. They developed and maintain a white paper that explains the grouting process and specifically how to make grouting jobs successful. They also developed standardized specification guidelines. It's a guide that provides engineers with enough information to make decisions about things like gel times and testing pressure, things that we used to rely on our operators. We're currently working on an inspector training and certification program for injection grouting, really to provide inspectors with the tools that they need to ensure the success of grouting projects. And finally, they put on educational webcasts and develop other educational materials for engineers, owners, and the rest of the industry on successful grouting projects. So you can find all of these references on NASSCO.org or the sewergrouting.com websites. But the ICGA's roots, and pun intended, I'm sorry, they run hand in hand with NASSCO's roots. You know, when NASSCO began, it was back in 1976, the country was celebrating the bicentennial, Rocky was running up and down the streets of Philly, and posters of Pharaoh were being unrolled, but there were very few standards in trenches technologies. Chemical grouting in 1976 was about 14 years old. And while good contractors were giving grouting a well-deserved reputation as a cost-effective method of removing infiltration, the lack of any real standards put system owners at the mercy of all contractors. So like with any other technologies, good jobs built confidence in chemical grouting, while bad jobs had just the opposite effect. So NASSCO was established to develop standards and ensure the growth of trenches technologies. And chemical grouting was a big part of NASSCO's history right from the beginning. It was important to companies who did chemical grouting that all the companies would be held to the same standards. So the Performance Standards Committee was one of NASSCO's first committees formed to address the lack of uniform standards back in 1976 and before, and particularly with chemical grouting. By 1978, a grout task force was started by Bill Thompson, James Witt, and Ray Barr, and some of the topics that they discussed back then were similar to those today. First of all, they influenced the EPA to fund research on grout alternatives, which would include performance specifications for all grouting activities. They promoted funding for private property or private laterals to address problems with private property I&I. Remember, this was back in 1978. And they educated system owners on the benefits of grouting with fact sheets and what we called sewer savers. So in 1980, NASSCO developed what was called the Inspector's Handbook. The Grouting Task Force also developed Grouting Longevity Brochure, the Grouting Facting Fiction Sheets, grout mixing and utilization forms, and a lot of educational resources like you see here. And by 1989, NASSCO had invested a significant amount of time and resources into grouting. But as it turned out, this was only the beginning. In 1990, the EPA released an acrylamide report, and NASSCO met with EPA twice that year. The proposed acrylamide ban that was proposed went on for 12 years until 2002, when the task force was successful in proving that the ban was really not necessary. So the ban was lifted for all the right reasons, and it was really due to the resolve of industry icons like Trent Ralston, Dave McGill, Norm Cerna, Bill Thompson, and actually our next speaker, Harold Kosova. You know, Mark Anktel is going to introduce these and many others who've contributed to the grouting industry and provide some more details on the ICGA. I'll tell you, though, I just want to say that these NASSCO members epitomize NASSCO's resolve in taking a stand for the industry through cooperative efforts of competitive companies. They came together for a common goal, and they really achieved those goals. So since NASSCO was formed, the grouting industry has exemplified NASSCO's charter to serve the entire industry by increasing the success of grouting contractors to grow the entire grouting industry. You know, we're proud to have the grouting industry, now represented by ICGA, as a part of NASSCO. So if grouting was a teenager when NASSCO was established, our next speaker was there when grouting was born, and you could even say he may have helped in the delivery. So it's my pleasure to introduce my friend, Harold Kosova. Harold?
Thanks a lot, Ted. You know, in 1949, National Power Routing was launched as a small sewer cleaning service. They developed and patented an exceptional piece of machinery, a continuous power router. Industrial plants and utility companies relied on NPR for the cleaning of blast furnace stoves, routing of underground utility ducts, and sewers. In 1960, National Power Routing Corporation hired me as a graduate of the Tech to develop a television camera that could televise sewer lines. Over the next few years, NPR began developing methods to help remotely repair faults revealed by the closed-circuit TV cameras. The path to success was difficult and necessitated many failed attempts as well as complications and problems. To solve the problem of pulling the camera through the line, NPR had to first develop a skid which could carry the television camera. NPR also had to devise proper lighting as well as proper cable for the camera, requiring 28 separate wires that had to be connected to a watertight connector. The connector then plugged into the television camera. The ability to use robotic technology to remotely repair sewer line problems was a major breakthrough, since it enabled the users to discover and repair a problem without the need to physically break through the street surface. This offered a significant cost savings to the company and to municipalities and industry. In 1962, NPR developed chemical grouting of sewer lines. The use of the television camera enabled NPR to perform pressure chemical grouting and sealing of infiltration in sewer lines. It also started with the need to eliminate infiltration within an 8-inch sewer line, 25 feet deep, in Cottonwood Falls, Kansas. NPR had our newly developed pipe TV studio, and the contractor had chemicals newly developed by American Cyanamid. These chemicals subsequently became known as chemical grout. AM9 was the first and only product. The contractor and I developed a packer that would inflate on either side of the sewer line joint. We then mixed the chemicals and using the grouting packer, pumped the mix into the sewer line joint and into the surrounding ground. This was truly an experiment, since no one in the industry at that time, including ourselves, could predict the procedure's success or failure. We pumped the chemical grout into all leaking joints, but were unable to get them to seal. Later, when getting to a downstream manhole, we removed the packer and proceeded to televise the sewer line again. To our amazement, all previously grouted joints were now sealed. We came to the conclusion that we had to underestimated the time required for the grout to test. Accordingly, we adjusted the chemical formula and we were able to seal an additional sewer line with no problem. There were plenty of mistakes made in developing a reliable grouting process. In one early instance, we used the same ore to mix two separate vats of chemical and found that one of the vats, the AM9 vat, gelled up due to residue from the ore from the first vat being an AP vat by using the same ore. We also had to find, through trial and error, the proper amount of pressure required for inflating the packer and develop an effective way to blow gelled chemical out of the hose. Today, the cost of treatments to just watertight systems are important, and municipal grouting is more than mainline joint. It is also manholes and service connections. It is critical that everyone using chemical grout be fully educated in its safe use. Contractors and engineers must be taught the comprehensive process and the specifics of where and when chemical grout should be utilized. I see companies like Avanti and organizations like NASSCO advancing the standards and growing the industry. I have had the pleasure to teach and mentor many people over the years. One of those was Pete Fleetwood, who now serves as a president of Bionomic Services in Charlotte, North Carolina, being one of the Carillon companies, and a most active grouting unit. And from one old guy to another, I am pleased and proud to introduce Pete Fleetwood as the next presenter.
Thank you very much, Harold. It's been an honor knowing and working with you for the past 40 years. This just isn't a story about early grouting industry. This is an American story. Americans have continually attempted to improve the lives of the next generations, even though they knew they would not experience the reward. By the time our country had reached the 1960s, we were polluting at an unsustainable rate. Forward-thinking scientists and legislators saw a need to protect and save the environment for the future. Discharge limits were set. Innovators strived to clean up this pollution with the best technology. Sealing leaking joints, sewer joints, was one of these innovations. Harold has given you the history of the innovation. I'll provide you with my memories of the applications in the 70s and the 80s. I started in the sewer rehab with video pipe services in 1971, before President Nixon signed the Clean Water Act, jump-starting our vocation. As a kid, I remember swimming and playing in the beaches of Lake Ontario. Dead fish and grease balls would be washed up on the sand. Later in my career, I recognized similar grease balls floating in wet wells. I remember cleaning pipes where the last downstream access was the river. This was not a random occurrence. Many small towns built their first treatment plants. Whole towns smelled like septic systems. Bypass lines and sanitary manholes connecting storm manholes were common. A very good solution for basement backups, but not for the creeks. How did we do it? What were the differences? Black and white camera weighed about 30 pounds. There was no pan and tilt. It was not self-propelled. We pulled it on a skid. Light bulbs were 500 watts, and they would burn you. Matter of fact, if you needed to light your cigarette, it was a pretty good option to light your cigarette if you're out of matches. Images were recorded on a Polaroid camera positioned in front of the monitor. In the 70s, we used the reel-to-reel video recorder. Then it soon progressed to a 1-inch cassette. By the 80s, VHS and beta formats were the tapes that were specified. Observation and sealing information was recording on a paper tablet where we logged in abbreviations. You can imagine how confusing our reports were prior to PACP standards. Every operator, every contractor had their own abbreviations and naming systems. In the early 80s, a computer-generated report came available, much more like the McDonald's cash register, joint with cracks, joint with roots, burger with fries. A rod truck and a winch pulled the bucket machine. A winch called a bucket machine were used to clean the pipe. The truck could contain 1,000 feet of rod. Gas tester had not been invented. Confined space entry was seldom with a harness or a safety watch. Once the line was cleaned and pre-TV'd, the rod pulled the camera in the packer, tagged by the cable from the bucket machine. Intercom was strung between the trucks, providing communication between the operators. Grout rig operator would relay, take it up, stop, spin, etc. The rod man would speak the footage when he stopped. The grout operator would log the footage on the tablet. A carbon copy for the customer and an original went to the office to be typed. Intercom signal was transmitted over a pair wire laid on the ground surface. If a street sweeper passed over the wire, communication disappeared. You weren't happy, nor was the street sweeper operator. When CBs came out, intercom was replaced. Initially, we didn't air test joints. Grouting was either consecutive or random. We manufactured our own packers. Look at the size of the void. Bladders didn't last nearly as long as today's. A straight pin could cause a leak. Also, the video cable and the hose were very heavy. In a dry pipe, you were a heck of a man to pull the packer into the downstream manhole to disassemble. It wasn't long until air test was specified. We had no packers for 24-inch, so in a 24-inch and larger, you crawled the pipe and drilled. Most important, until the last couple of years, I thought I knew all there was to know about grouting. Heck, I've been doing it since I was 20. Before many others in the business were born. I was wrong. Temperature change, percent solids, gel times are relevant to quality. Jim Shelton, who's going to follow, gave me information that I had not considered. The industry is improving. Harold's group gave us the technology. My group utilized it. Now the next group needs to use today's technology to continue the progression. Our goal is a sustainable environment for the next generations. The American story. I'm honored to introduce Mark Antill. He has been with Lodgeball for 22 years. He worked his way up to become the president. I enjoy him professionally and personally. Not only does he produce quality equipment, he can come up with some of the off-the-wall applications that I dream up. Mark?
Thank you, Pete. There's been a lot of industry game changers over the years, and I'm going to try and explain some of these to you, so please bear with me for the next few slides. One of the reasons we're still here, or when this got started, is because of the Clean Water Act of 1972. We decided to take care of basically every water that was out there, not polluting. In 1981, as mentioned earlier, the EPA had a proposed ban on acrylamide grout, and one of those reasons was basically the PPE for the operators. As you can see from these pictures, times have changed. One of the reactions to the proposed ban was a push for alternate grouts, but the equipment of those times and delivery systems through remotely operated equipment were basically not the best match for these new alternate grouts. Well, NASSCO and the Grout Task Force spent many years discussing and I'd say fighting the proposed ban on these grouts. In 1977, CIPP was invented and Insituform had the patent. When the patent ran out in 1994, this technology became available to all, and there was a greater need at that time to stop pre- and post-infiltration of the installations. Now that a lot of work had been performed on main lines, the groundwater infiltration was not disappearing. You would see water come in at the pipe-to-manhole connections and also at the reinstated service laterals in the relined pipes. So in the mid-90s, lateral packers became available and were used to stop this infiltration at the connections. In 1998 and 1999, too, the associations presented their Most Innovative Product Award to people in our industry, recognizing that chemical grouting definitely had a place, or injection grouting had a place in the market. Back in December 2002, the EPA had removed its proposed ban, and now that appropriate PPE would be used by the operators, acrylamide grout was back. ICGA became a division of NASSCO. Led by manufacturers, suppliers, and installers and professionals. Their goal was basically to promote the proper use of grouting as a safe and economical means to permanently stop groundwater infiltration. Standards. Not that there's a lot of work being done out there. We need to increase the level of quality achievement and laterals. To be done on the outside of the structures in order for this repair to be permanent. In 2006, NASSCO and ICGA members, led by Dick Shans from Mary's, got together and formed a multi-vendor passion, the first grout boot camps, where people come in, whether it be 20 years in the business, new ones, inspectors, engineers, for 2 days, come in, sit down, work, and try and understand what the grouting process is all about. This is 10 years old, and we've now trained over 450 people at these classes. Today's capabilities. Well, if we go back 40 years ago, and what we can be doing today is totally different things. We're sealing laterals from only the mainline access up to 30 feet. We're sealing pipes up to 12 feet in diameter. We're sealing pipes that have elliptical shapes. And we're coming up with solutions to basically problems that we encounter there on a daily basis. For the next presenters, it's my pleasure to introduce to you Ron Manistar from Mary's Industries and Mark Schneider from Q's. These two gentlemen have a wealth of knowledge in the delivery and camera systems. Ron?
I'm going to take it, Mark. Thank you. First, people, don't be fooled by my picture. I'm very happy to be here speaking today. Ron and I are going to be talking about the equipment and used in the grouting process, and I'm going to start with chemical hoses. The chemical hoses were originally started with 3 hoses, like was said earlier, which just basically allowed 1 hose for each chemical and 1 hose for air to inflate the packer. Later, the hoses moved on to 4 hoses, which gave the ability to add an air medium or a water medium to allow to test the joint to confirm whether it would need a grout or not. Eventually, we moved into 5 hose systems, which helped better facilitate Mark's lateral packers, especially when they needed to lateral test. The 5th hose is typically used now to do the air test, because the 4th hose was then needed to inflate and deflate the lateral sock. Hoses ranges from lengths of from 500 to 800 feet and typically include some kind of dripless fitting or check valve on the end of the hose to keep the chemical from leaking out when it's disconnected from the packer. I'm going to pass this on to Ron. He will continue with packers and other parts of the system.
Thank you very much, Mark. Here we have an example of 2 packers, an 8-inch and a 10-inch. They are each individually sized to work in a specific diameter of pipe. They are built-in check valves that control the chemical flow as it goes into the pipe packer void. The 24-inch packer can be disassembled to pass through a standard manhole opening. It has a built-in sensor to test the integrity of the joints with air, enabling this information then to be displayed on the grout control system. A lateral packer is designed to grout the connection at the main line. The packer can rotate so that the connection between 6 to 4 o'clock can be grouted. Lateral sealing distances can be varied from 36 inches all the way to 50 feet. Here we have a lateral packer that is being used to grout the connection all the way to the property line. Grout trucks for many years were built into step vans, affectionately called the bread truck. Very popular for many years and an industry standard. With newer vehicles now growing much larger because of safety and productivity requirements, a lot more equipment is now being installed into these trucks. Chemical tanks have increased in size from 30 gallons to 60 gallons. This increase in size reduces the amount of time that the grout technician needs to mix chemicals and enables him also to improve his productivity. Electric pumps, with their variable speed capabilities, can be controlled so that the flow matches the pathway opening through the pipe into the surrounding bedding material. The air system needs to be large enough and sized properly so that there is no loss of performance while inflating the packer and the lateral plug. A vacuum system is necessary to pull the air from 800 feet of hose and a lateral plug, enabling the lateral plug now to fully invert back into the packer before continuing down the pipe. The first pan and tilt cameras allowed the grout technician to view the joint and into the lateral connection. Over the years, there have been improvements with zoom capabilities, LED lighting, and camera diagnostics. And improvements are still being made with smaller cameras and wiper blades to remove the debris from the lens. Mark, I'll turn it back over to you.
Thanks, Ron. Now, there was something needed to control all of this equipment, and some kind of panel. Now, the first panels you saw earlier were air-over systems, and all was really needed was a sight tubes and control valves to push the chemical in, and a valve to basically inflate the packer. When pumps were used and introduced, the panels moved on to manual panels. These combine the packer inflate and test control regulators to the other controls, which would be to check for the amount of chemical used, air test pressures, all that information was brought in. Also, panels were introduced to control the ladle packers that were typically added onto these type panels. The latest technology allows for remote panels, which control a panel that has regulators and valves inside it, and is all controlled by computer. This allows for the industry specifications to be entered into the software to make sure the operator conforms to these specifications, such as minimum test pressures, packer pressures, and duration of the air test. This technology also creates a live graph of void pressure to help operator adjust the grout pump rate as required and also watch the gel time. The computer control also allows for much more data to be recorded than the original handwritten reports or manual entries into today's pipeline softwares. Don?
Yeah, very good. Thank you, Mark. It's time for another poll question, and we have 3 of them all total. The next one is, let me send this survey out. Looking back, which technology used in grouting has advanced the most? I'm looking for a single best answer here. I'm going to give it a couple of seconds, and I'll play back the results for everybody. I think that's always interesting. Trusting you see the question and the answers are coming in good. Slowly. Let me go ahead and end this whole question and play back the results. Send results to audience. And looking like remote packers and conveyance equipment, very close with CCTV. Folks, thank you very much for that, for those responses. Look, I'm very pleased and excited. Let me go back to pleased and excited to introduce our next speaker. He is professor of civil engineering, civil and environmental engineering at University of Houston. He's the director of SIGMAT, Center for Innovative Grouting Materials and Technology, and an R&D resource for Avanti. Please welcome Dr. Vipul Landadan.
Thank you, Don, for introducing me. Now I'm going to, in the next 5 minutes, talk about some of our research activities and some of my advancements and some of our challenges in working with grouting materials. So that's what I'm going to do. So what happened here? Fortunately, none of us are in this car. What happened? This was a sinkhole created by a human, and what caused this sinkhole? It is due to infiltration or inflow into some of our sewer systems. And so we know this problem, and the question is, what can we do with it? And this is what we are running into all the time. Every city has it, and we are looking at it from different angles. So one of the things that we from the university wanted to make sure that we document all this. So this is very important. This document is a white paper, just control leaks in sewer control system. So this documented all the needed information that people like to see, and also summarize some of the inspection technologies, how good they are, how reliable they are, and also summarize some of the grouting methods that can be used. Also, another important thing is to document the case studies of that we know about, because documentation is important. So we went ahead and also worked on getting some information with the American Society of Civil Engineers. So we have been working with them to get publications out. This is just a proceeding grouting, and it's a little old, but this also is referred by many people around the world, so because it's documenting quite interesting topics. Also, you heard today about how EPA had made some impacts. So we also, when SIGMAT was formed, David McGill was one of the people to help us. He challenged us, say that we have to work on getting the word grouting on the EPA website, and here we are. After several years of hard work, EPA approved us to do the verification protocol on grouting materials that are used for pipe joints, manholes, laterals, and concrete cracking. So this is a documentation where we came up with the test protocol. As you all know, standards are very limited in grouting, so we came up with our standards, documented it, and got it approved by EPA, and then we have done so many tests on different grouts for different applications, and I thought I'd share this with you all. Where if you do a repair on a lateral, how does the inflow stop? You can see from this figure how the grout gets out and actually reduces the permeability of the filling material. And you can see the shape of it. We have done modeling on all this, so we want to clearly explain the fundamentals of it, and this gets people to think about how they should be grouting to seal the joint. So this is what it is, and this is all documented, and then I'm going to move on because research goes on, and now you can see what happened here. This is a major disaster caused by cementing failure. It's all documented very well, happening all over the world. Why? We use cement to hold the casing in the oil well to the formation. It's very similar. It's a grout. And then we have a lot of problems, and you see the major failures, major disasters. So the challenge is, what can we do with it? Can we stop this? Answer is yes. We have worked on it. We were fortunate. We worked on it, and we have developed a new concept for this. The cement, as of now, we cannot say what's happening in the cement. We don't know whether cement is hardening, cement is what's happening. We have developed a new concept. We have developed what we call the smart cement, so that the cement is a sensing material by itself, and it can tell exactly what's going on in the cement, and then we can monitor it and prevent failures before a disaster like this. So we were fortunate. After this disaster, Department of Energy, DOE, gave us $2.5 million to develop my new concept of smart cement. And we just finished up this report. It's a 4-year study where we developed the material, demonstrated it at different scales, and we have a model well that in the field we have cemented it using our smart cement, and it is working very well. So as you all know, Romans developed this cement for application thousands of years ago. Somehow we just kept on using it. Now with our new ideas, my new ideas, we are moving on with new thoughts of how we can make all our grouts to be very sensing. So we have really not only made the cement to be like our skin, I have also built the brain system to monitor it and tell you. So it's a complete system that we have developed so that you can monitor the cementing during the installation and during the entire service life of the well. So we developed this concept recently, and now we want to move on with this knowledge that we gained into the grouting area. So we are really now working and developing smart cement grouts and also smart polymer grouts. And we are making them very sensing. This is research, it's ongoing. We are making the grouts to be chemothermo piezoresistive. That means they are sensitive to the chemical, sensitive to the temperature, sensitive to the stressors. And the monitoring system has to be developed. That's very important. Models have to be tested out, and also we have to quantify an analytical model. So basically what our future direction is going to be developing these smart grouts with different compositions, but We are going to make them very sensing, and we don't bury sensors in the material. The entire material is a sensor. It's a bulk sensor. That's what the traction is, and our modification is less than 0.1%. So if you buy 1,000 pounds of cement, it's less than 1 pound, and we are now moving into polymer grouts and other types of grouts to do this modification. So you can see in the when you do the grouting, is the grout solidifying? Is there any fluid losses in the formation, or is the grout getting contaminated, or there is leaking problem continuing? All these can be monitored with this smart grout. So this is we are pushing for the new technology. So in summary, I just want to let you know that over the 30 years of development, we have worked hard, and now EPA has a verification program for grouts, testing and verifying grouts, and also grouts have been used in so many applications. You had so many speakers before me talk about it. It's been used for soil improvement, treating contaminated soils. We are using the grouts for concrete cracks and others to prevent leaks. So this is ongoing. So where do we want to go next? Our next major focus is going to develop this smart grout, so that when they do these operations, they can continually monitor what's going on with the grout and how to monitor it during the entire service life. So with that, thank you very much for your attention, and I'm very honored to introduce the next speaker. He is going to talk about current grouting practices, John Manichek, who has 22 years of grouting experience, which is really remarkable, and he is the estimating and business development manager for Municipal Corporation in Chicago. John, all yours.
Hey, thank you, Dr. Vipu. I've been around for 17 years, but I'll take the extra 5. Earlier we heard chemical grouting had its beginnings in the mid-50s. Its development and use excelled through the 60s and 70s, but it was in the 1980s. Cured-in-place pipe, otherwise known as CIPP, was introduced to the world and quickly took the place of chemical grouting as the #1 trenchless technology. CIPP, known for its high structural strength and 50-year design life, became the sole choice for engineers for rehabbing sewers. It was believed by engineers that CIPP had a chemical bond to the hose pipe. But what they didn't know is this: CIPP, by design, is a standalone product. It is not reliant upon the hose pipe. If anything could be said, it is that CIPP has a mechanical bond. So why is this fact so important? Because CIPP has an annular space, and that is caused by the cooling of the product. The hose pipe still has the cracks, the fractures, and the open joints. The water, the infiltration, still enters the pipe through these openings. It travels along the annular space, and it enters the system at the lateral reinstatements and at the manhole terminations. Today, we are using chemical grouting to seal annular space in CIPP at the lateral openings and in the manholes at the termination points. By using a lateral packer, we are able to inject acrylamide grout into the annular space and also to the exterior of the lateral connection, post-lining. We're going back into cured-in-place pipes and creating a watertight mainline system by using CIPP and chemical grouting as a complementary technology to one another. In today's world of pipe rehab, engineers are quickly adopting the practice known as the holistic approach to eliminating infiltration. That is, to completely eliminate infiltration, all 4 points of possible entry must be addressed: the manholes, the mainline joints, the service line connections, and the laterals. Water migration is real. Water travels along the sanitary trench and will enter your system at any of those 4 points. If you address 1 or 2 of these points but ignore the others, water will quickly find its way to the other points of entry. We are beginning to see proactive maintenance projects come out for bid where the engineers are now using a combination of technologies, that is, cured-in-place pipe, chemical grouting, manhole rehab, and lateral grouting. together as complementary technologies to achieve a completely watertight system. If the pipes are in good condition, we will test and seal the joints with chemical grout. If the pipes are cracked and fractured, we will line them using CIPP. The laterals are being addressed with grouting and lining from both the main lines and the cleanouts. And finally, the main manholes are being curtain grouted if they're in good shape, or lined with concrete and epoxies if they need to be rebuilt. I have been involved in a number of projects, but there is one that will always stand out in my mind, and that is Naperville, Illinois. The area in which we were working had a high ground water table and a very big problem with active infiltration, so much so that we had to grout the mainline joints and the laterals before the main lines were lined. Without grouting first, there would have been a problem of resin washout in the CIPP as it was being installed and cured. Once the main lines were sealed with grouting and lining and the laterals were sealed using a 38-foot sock, the manholes themselves began to leak. The water, having no entryway into the system, had migrated to the manholes and was preventing the installation of the lining product. Once they were curtain grouted, the manholes then could be lined, and then the project was completed, addressing all 4 points of infiltration. Today, we are using chemical grout in a variety of ways. We are testing and sealing mainline joints and structurally sound pipe. We are sealing laterals from both the mainline and the cleanouts. We are sealing manholes by curtain grouting, and we are using chemical grout to seal the annular space in cured-in-place pipe at the lateral connections and the manhole terminations in both newly installed and old liner pipe. Next up is Jim Shelton. Jim's a good friend of mine and the Vice President of Buried Infrastructure at Arcadis. He leads a team that works closely with utilities to conceive, develop, and implement rehab solutions, especially around I&I reduction projects. Jim?
Thanks, John. So most of my job is dealing with utilities and helping them figure out what technologies to bring. When it comes to speaking with them about grouting, they always ask the same 2 or 3 questions. How effective is grouting at eliminating I&I, especially the groundwater infiltration? How long can we count on it continuing to do that? And then as John said, given the preponderance of lining work, how does it compare to lining from a cost standpoint, from an effectiveness standpoint, from a longevity standpoint? I think it's worth saying that if you do grouting incorrectly, it's not going to last. And that's been the experience of many folks. When it's not done properly, 6 months to 2 years is very common. But we knew that there was a proper way to do this, and going back a decade or a decade and a half, we were predicting about a 15-year life for grouting, and we were assuming at the time about a 25% I&I removal if we used it holistically. Since that time, we've been able to do 2 things. We've been able to go back and do some medium-term testing. This is work that was done 7 to 10 years after the grouting work was done. We went back and we actually retested the exact same joints and tap connections that were done and found an extremely high rate of pass. They were holding up much, much longer than we thought. We also now have the ability to address additional defects and lateral components that we did not have before. Taken together, these things allow us to remove at least 40% on a regular basis of the leakage that's coming into the system, as well as we're at this point now we're willing to predict that at least 25 years of effective sealing life will be achieved. It may be longer than that. We simply don't have enough of a database to really be able to predict beyond that. But in order to get those types of performance numbers, the work has to be done following very strict rules in order to achieve the longevity. And it has to be done holistically. You've got to do not just the mains, but the manholes and the laterals. The more of the system you do, the higher your I&I reductions. From a cost standpoint, grouting is about a quarter of the cost generally of mainline lining, and when you combine that with lateral lining, it generally comes in to be about an eighth, or about a tenth of the cost of replacement of the job. But you know, there's a couple of ways of looking at cost. From an initial capital cost standpoint, grouting is always the lowest priced alternative. It is also often the lowest life cycle cost. If you consider that lining is figured to last 50 years, if you project conservatively that grouting will last 25 years, even when you figure in that mix, it still generally delivers the best life cycle cost. When you also start to figure in your bang for the buck on I&I reduction per life cycle dollar, it's typically the greatest bang for the buck. So how do you get these kind of results? The single biggest impact on the life and the effectiveness of grouting is the quality of the installation. It's directly related to the specifications and the oversight. That's both the contractor oversight and the inspector oversight. How well you seal it, how much leakage you remove, is directly related to how much of the lateral is sealed. So those long lateral grouting attempts or efforts make a big effort in reducing the flows. Also, you're going to have defects there in place, so how well those defects are managed also will affect that. And in the end, it's also related to the quality of the grout. Anything that's going to remain in the ground for 25 to 50 years has to have robust characteristics to last a long time. About 5 years ago, NASSCO and ICGA put together the first of their suggested standard specification. This was an industry collaborative effort to try to codify what was in the ASTMs and what was being done in practice. That document's been around for about 5 years now, and it's really governed what we've been doing. We're in the process now of completely rewriting that spec and converting it from a suggested specification to what most engineers are used to, which is a master specification, which will have full instructions to engineers on when to do different things within the grouting world. There's an awful lot that happens in the field, and understanding how your specification should accommodate are an important part of getting effectiveness and longevity. Now comes my favorite part. There's only two things that engineers really get to do. We get to think about the future, and we get to make up acronyms for things. So let me talk to you about my acronyms and what I see looking in the crystal ball. In the next 2 years, I think we're going to perfect the longitudinal fracture defect grouting packers that are going to allow us to do not just circumferential fractures, but also spiral, longitudinal, and multiple fractures. And advance that from a pilot practice that's been extremely successful to becoming a standard tool in all grouters' toolboxes. I think we're also going to see the perfection of what we call LACO packers, or laterals access to clean-out packers, to allow us to grout all of the lateral from the clean-out all the way back to the main. Many laterals are 80 feet, 90 feet, 100 feet long. The ability to get the leakage that's coming into the terracotta portions of that are extremely important. We've piloted many of these tools and practices. I see us going to a standard practice. We're also working on developing a NASSCO certification program. This is a new ITCP program that's focused on teaching engineers and inspectors how to specify and inspect grouting works so that it's consistently and reliably done. I see that time also where we see widespread use of double sweep tees being put in at the cleanouts that allow us to eventually do the part of the lateral that goes to the home, that brave new frontier of the private side, which eventually will have to be addressed in order to get the leakage that's happening on that portion of the system. You heard the guys talk about ultra-long lateral tap packers. I see the day when we can get to a 50-foot packer, but not only a 50-foot long sock, one that's able to negotiate multiple diameter changes and changes in direction at the same time. So we're effectively able to get a huge amount of the lateral from the main line. A lot of the work I do has to do with interceptor systems that are typically built with reinforced concrete. And many of those have issues with surface protrusions where the corrosion is eating away at it. I can see a time coming in the next 5 years where we have packers with specialized rubbers on them that allow us to really grip into aggressively protruding aggregate, to allow us to save all that money we're spending on lining simply because we've got a few leaking joints in a concrete pipe. And I also see us finalizing the formulation of the additives that we're putting in acrylamides so that we improve its resistance to dehydration by 50% over where it is today. It's very good today. I see it getting even better. I think we'll also be at a point soon where we'll be able to optimize how much grout volume we put out in each diameter. Typically, we follow the rule of thumb of a quart per inch diameter. That's an ASTM standard. We want to try to optimize that and optimize the grout pumping rates as a function of leakage so that we can get that amount out there. The electric pumps that you saw in the earlier presentation are certainly going to take us away from the air pumps and allow us to do that. In fact, I can see a time when actually that pump rate is completely automated, adjusted based on what the fall rate is when we test the joint, and it adjusts the pumping rate so we're able to get our estimated amount of grout out there. 5 years from now, we'll be going back into the areas where we did the 10-year study, and we'll be completing a 15-year study for grouting longevity. That'll allow us to predict, I foresee that will allow us to predict the grouting is going to last 30, 35, 40 years, as well as going back to an area where we did the first large-scale tap connection system using grouting to seal the annular space and doing a 7-year longevity testing program for there to really confirm in a very engineering-specific way just how well that type of approach works. I think 5 years out from now, we'll also modify the ITCP program so that we're also certifying the grout installation technicians so that not only are the engineers and inspectors trained and certified, but the technicians actually installing it have a defined level of expertise. At the 10-year point, I can see us having completely new grouts. Grout that's completely immune to dehydration. It's got adhesion properties so that when we grout longitudinal defects, it actually glues them back together. And it's got the flexural properties to deal with seismic areas. It's got the stretch properties to deal with sea level rise changes and the increased pressure that's being placed on grouts. I see mainline launched lateral packers being changed over from where they are now with long socks to being discrete joint testers and cameras installed. So we're not using so much grout to get those 50-footers, but we're discretely testing every single joint in the lateral tap connection. This is important because fully 2/3 of the tap connections that exist in our system exist in our laterals. I'm sorry, not our tap connections, our joints. I also see a time when we've got a completely automated gel time system, gel testing system that allows us to adjust the gel set time based on temperature continuously, so we always have an optimal amount of flow going out. And for that matter, a completely robotic visualization and artificial intelligence system that completely automates the test and seal aspects of the work. That'll double the production of a 2-man crew. It'll optimize the grout delivery quantities. And it'll cut in half the cost of delivering this already inexpensive service. And then my big dream, and it's one that's going to take a lot of work, is to develop a grout technician that doesn't chain smoke, gets his primary nutrition from something other than Doritos and high caffeinated beverages, and has a calendar that I can bring my kids into the studio and not be embarrassed and have to explain it later. With that, I'd like to turn the presentation over to Daniel, who will talk us through the closeout of this.
Awesome. Thank you, Jim. Grateful for the opportunity to tie all of this together. We've just heard from some bright, credible, resourceful people. Some are practitioners, some are innovators, others are educators and advisors, but they all have one thing in common. They're all problem solvers. And we most definitely have a problem worth solving, not just for us right now, but the future generations, as Pete Fleetwood suggested. Infiltration is responsible for all kinds of issues that we've seen here today. Sewer overflows, increased cost, decreased capacity of our system, including sinkholes in many cases. And we collectively are responsible for solving infiltration problems, both for small communities and for large sewer districts. And of all the trenchless technologies available, only one is engineered specifically to stop infiltration at all points of entry, and that's injection grouting. John Manajek stated that grouting is complementary to CIPP lining. In fact, we're seeing a trend among collection system managers and their engineering consultants to grout prior to lining. Why is that? Because lining doesn't stop infiltration. It reallocates the groundwater to another point of entry. It also doesn't stabilize the soil, whereas grouting stabilizes the sewer trench around the pipe, making that lining solution more durable. So they really work together. They go hand in hand. Injection grouting is both a proactive maintenance practice and it's an engineered construction solution. And the look back at the early days of trenchless technology as shared by Harold Kosova and Pete Fleetwood helps us realize how far we've come. Thank you both for that. Dr. Vippu and Jim Shelton encourage us to keep investing in R&D, and both of you, I love hearing your vision for where the grouting industry is going. It's awesome. Logiball, Q's, and Aries, You guys remind us that we're not alone, and we're in this together. Together, we're better. If that statement resonates with you during this election year for our 45th and what feels like our final president, then here's another one that you might relate to. Let's make America grout again. That would be, as we say around here, grout standing. On that note, here's an Avanti future promise to municipalities who truly own the problem and to engineering firms who are accountable for their recommendations and specifications. Avanti will continue to maintain a leadership role within NASSCO and ICGA to continue advancing operating standards. And we'll continue investing in R&D and smart grouts for conveyance technologies to bring more specific scientific data to testing additives and design life and to growing the industry as we've done since 1978. I'll end on this slide. This is a picture of our aquarium here at the office, and you can see the fish are swimming around on top. But if you look at the bottom of the aquarium, it's dry sand, and that's the whole point. It's fun to look at, but you can see after we poured in the acrylamide grout, the sand on the bottom is totally dry. The water is kept above the grout. So after all of this, what do we hope that you will do next? We hope that you will become a lifelong student of grouting. The more you know, the more you'll want to know. And number two, consider a pilot program. Evaluate the reduction in infiltration and also the reduction in maintenance costs. And finally, give the taxpayer a break. You're looking at a less costly, more targeted solution to controlling infiltration and to sustaining our asset collection system. Thanks to Trenchless Technology for hosting this educational opportunity and also for establishing World Trenchless Day. I think that's awesome. It's great to bring more attention to our failing infrastructure. Cheers.
Daniel, thank you. And before I turn this back over to Sharon, I have one more poll question to ask, and I'll send this survey out to the audience now. Question is, looking forward, where would you like to see more innovation from in municipal grouting? Where would you like to see more innovation? Assessment tools, process, procedures, grouting materials, conveyance equipment, engineering specification. I'm going to leave it open just for another moment and then close it so I can share it back to all of you. Numbers are pretty dynamic here. Let me send the results out to the audience, and it looks like process and procedures quality executed by contractors looks like numero uno. Very good. And with that, Sharon, would you like to finish up with some closing comments?
Sure. Thanks, Don, for your assistance this afternoon and for everyone at Avanti for making this webinar possible on World Trenchless Day. And, of course, much thanks to each of the presenters. Before we wrap up this webinar event, I wanted to let you know a few things. Within 24 hours, you can expect a link to the recording of this multimedia presentation. Feel free to share with others to extend the learning, and you can expect a link to the NASSCO ICGA suggested operating standard. Within a matter of weeks, you can expect a FAQ document with answers to questions submitted online during this webcast. And as you exit this broadcast, you can expect a short exit survey, including details on how to receive continuing education credits for your participation today.